Hey everyone, welcome back to my channel. Today we're diving into subnetting, a topic that might sound like it belongs in a sci-fi movie, but trust me, it's way cooler and easier than you might think. By the end of this video, you'll be able to slice into networks like a pro chef cuts into pizza. Plus, I've got a bonus tip on a tool that will save you from math-induced headaches. So grab some coffee and let's get started. All right, what's subnetting? Imagine you're hosting a huge party and with hundreds of people in one giant room. It's chaos. People are bumping into each other and you can't keep track of who's who. Now, if you split that room into smaller sections, say one for gamers, one for foodies, and one for dancers, it's way easier to manage. Subnetting does the same for networks. It takes a big network and divides it into smaller, more organized subnetworks or subnets. This helps with organization, security, and even makes your network run smoother. Well, why bother? Well, subnets keep things tidy, like separating your network devices from your smart fridge that keeps trying to order ice cream. They also reduce network traffic and can stop hackers from sneaking into every corner of your network. Pretty neat, right? Before we subnet, let's review IP addresses. An IP address is like your device's home address on the internet. It tells data where to go. We're focusing on IPv4, which looks like this: 192.168.1.1. It's 4 numbers called octets, each between 0 and 255. Now, each IP address has 2 parts: the network part, which is like the city you live in, and the host part, which is your specific house. To figure out which is which, we use a subnet mask. A common one you will see in personal use is 255.255.255.0, or in shorthand, a /24, because it uses the first 24 bits of your network. So for 192.168.1.1 with a /24 mask, the first 3 octets are 192.168.1, which are the network, and the last octet, which is 1, is the host. Easy peasy, right? We know this because if the corresponding subnet octet is 255, that means that number is locked in. All right, so let me show you exactly what I mean. So you have a 1.1 and a /24 is going to look like this: 2.255.255.0. So when I say that they're all going to be locked in with the corresponding 255, none of these are going to change. All right. So now what the /24 means is that's how many bits there are, how many ones there are. So what this would look like is this: 1, 2, 3, 4, 5, 6. This is what a /24 looks like. You got 24 bits on. That's your 24-bit mask. Now, before we move on, I want to go ahead and cover how to change your binary to decimal quick, and vice versa. So let me go ahead and erase this. We're going to practice with this 192.168.1.1 real quick so we can see how that works. And the way we're going to do that is we're going to have a fun little chart, a little conversion chart, and makes it real easy. I believe it's called the powers of dose or twos chart, but call it whatever you want. It works great. So you start from right to left, go 1, 2, 4, almost put a 6, 8, 16, 32, 64, and 128. So the way we're going to go in and convert this right here into binary is by doing a little adding and subtracting. Okay, so right now we're going to take this 192 and we're going to see if we can take this away from, or take 128 away from 192. I think we can. I hate math, so I'm going to do it on the calculator. So what we have left here is 64. So that means this bit is on, and then we take the 64. Can we take 64 from 64? Yes, we can. So I don't need a calculator for this. This one is also on. That means the remainder is 0, which means the rest of these are going to be off. Doom, 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 doom. That's how you go from decimal to binary. Now let's go ahead and flip it. We are going to erase all this. All right. And I'm just gonna pick some random binary stuff. Make sure it's all nice and clean. All right, so we're gonna go 1, 1, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, same chart. We got 1, 2, 4, 8, 16, 32, and 64, and 128. And all you're going to do is line up the ones and the zeros. And we have 1, on, off, on. So now we're going to drop these down. 128, 64, 192. All right, and then we're going to take 192 plus 32. That'll be 4, 12, 224. I'm recording plus 4 is 228 plus 1 is 229. I believe that's correct. I got thrown off by my wife. Now that you've been introduced to conversions from binary to decimal, decimal to binary, I think you got it. Let's move on to adding networks or subnetting. So the first thing we're going to do is erase all this stuff. Actually, there's an easier way. I'm still new to this Epic pen. It's really cool. You should check it out. So there we go. Boom, it's gone. So now we're going to go ahead and do some subnetting. So we got the 192.168.1.1. And then we have our subnet mask, which is 255.255.255.0. This is what we have. And we want to have, let's say, 4 networks. So let's go and bring out our chart. Our 1, 2, 4, 8, 16, 32, 64, 128. And now we're going to get our second conversion chart. And that would be 2, 4, 8, 16, 32, 64, 128, and that's 256. All right, so these are your 2 charts you're going to need. So we need 4 networks. So we got 1, 2. We have 4 networks. So we're going to count from 1 to 2. Real simple. Boom. That's going to be our range. All right, so this bottom one, it helps us with finding out how many networks, how many bits we're going to need to borrow. So remember, for the 255.255.255.0, that's going to look like this. We got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now we know we need to borrow 2 bits. So our /24 is going to turn into a /26. So now that we know that, we can go ahead and erase these 2. And we're going to go and flip them on. So it's going to go 1, 2. So that's our /26. And now we can use our little conversion chart to figure out what that is in decimal. So let's go ahead and erase some things. And let's see if we can figure out what that is in decimal. So we know the first 3 octets are going to be 255.255.255. That has not changed. But where we borrowed the 2 bits, we need to figure that out. So that will be a 1 and a 1. So we add those together and we get a 192. That is our number. So it's going to look like this. Our new subnet mask is going to look like this. 255.255.192. And if you remember, that gives us a range of 64. So our range is going to look like this. So we're going to have 192.168.1.0, which is going to be the
network ID
all the way to .63. All right, so 192.168.1.63. That's going to be our first range. And everything in between, which will be a .1 to 62, that will be our usable hosts. Usable hosts. All right. That is how you figure it out. So I want you to pause the video, and at the end, I'm going to go ahead and show you exactly all the answers for this. But I want you to try to get the next 3 networks and see how well you do. Post them in the comments. I want to see how you did. Work out the math, chat amongst each other. I think this will be a great exercise for you. Now, I want to show you the cheat code. Maybe use this first before going on to the cheat code, but the cheat code is something my professor taught me, so free college education for you guys. This is what we're going to do. This is the cheat code. Are you ready? This is going to make it so easy. And before I show it to you, I want to tell you that you need to know that other stuff, the binary first. It's going to make it so much easier. But for any Class C subnetting, it's going to make things a whole lot easier. So here we go. This is your subnetting table, right? So this is a Class C. So we're going to start out with the subnet mask, and we're going to fill out this table real quick. So we got /24, 25, 26, 27, all the way to 32. Now we're going to do the subnet. So you count from 1 all the way up to 256, kind of like remember the second table that I showed you? That's it. And then hosts, boom, complete opposite. So the first thing you're gonna do is the subnet mask, the /24, all the way to 32. Right. So remember the ones. So that last one was a 24, and he goes all the way up to 32. Now you're gonna do the subnets, which is, if you recognize the pattern, is 1 to 256, and then you're gonna do the host, which is the complete opposite. I hope this is making sense. If not, please drop a question down in the comments. I'll be glad to help. This is something that's going to take some practice. Subnetting is one of those things that you're going to learn, most likely forget after you take your test, and then you're going to have to learn it again when you go to do other things. Next, we're going to subnet using this chart, and we need 7 networks. Well, if we look at the subnets, we have 1, 2, 4, 8, 16. Okay, so we need 7. So 4 isn't enough, but 8 is. So we're going to go ahead and choose 8. Right. So the next part is going to be to fill out this second chart. All right. So you have the network ID, the subnet mask, your range, your usable host, and your broadcast. So let's fill out the network IDs. The way you're going to do this. All right. So we have this right here. We need 8. So the range will be 32. That is going to be your range. What you're going to do is you're going to take the first one, which is your network ID, which is a .0, and add 32. And you keep adding 32 until you get down to 7 networks. There's some of you that might notice that there's one that you're not going to be using, and that's okay. We'll call it, we're being ready for growth. All right, so again, /27, 27 ones. Easy peasy, we got it. Let's move on. There's our chart. All right, that's the subnet mask. Remember the conversion from decimal to binary. That's it, easy peasy, we're moving on. Our broadcast is always going to be the last one in that range. So the easiest way I could tell you to do this is to take the next one and -1. So the next network ID -1, that's your broadcast. And we're gonna fill out all the broadcasts until we get to the end here. So 23. Usable hosts, obviously we have 30, because remember, our range is 32, but our usable hosts, you gotta subtract 2. You always subtract 2 because you have your network ID and your broadcast. And then the range, fill out the ranges, .1 to .30, .33 to 62, and so on and so forth. I hope I'm not going too fast. It's a little more difficult to teach this, I think, in my opinion, to teach it to a camera as to a person with feedback. So please, if you have questions, feel free to drop them in the comments. Now I'm going to introduce you to a tool that is going to make your life so much easier. So while you're practicing, you can use this tool to check your work. You can't use it on the test, unfortunately, but you could use it to check your work. And it's a tool called IPCALC, and it runs on Linux. And I've done a video on how to install Linux, or Ubuntu more specifically, onto your Windows device. So let's show you how to install it. Watch that video install it, and then come back to this one. But this is how you would install it. So you do sudo apt install IPCALC. That is it. All right. Once it's installed, we're going to go ahead and run some commands. Now we're going to use the example from earlier. That example I promised you an answer for, and this is how I'm going to show you. This tool is really cool. You do IPCALC and then the network, which is, what was it? 192.168.1.1 and it was a /24. You could also write it out too if you want. Do 255.255.255.0, but CIDR notation is much easier. You can do attack S, and then we needed 4 networks. So the way you're going to do this is you're going to find out how many usable hosts you need, right? So remember, if we need 4 equal networks, we divide that range from 0 to 255, which is 256 addresses, by 4, divided by 4. That'll give us 64 minus 2, which is 62. So we're going to go ahead and do 62, 62, 62, and 62, and hit enter. And that is how you check your work. All right. If for anybody that paused the video, let me know how you did. I would love to know. And of course, any questions, please reach out. I'd love to help you. And share this video if you found it helpful. Like it. Let's spread the word. All right. Well, thank you so much for watching, and you have a good one.